Now for 13, we have this plus this equals 0. And I noticed that these two terms have a cosine in common. So I'm going to take out a cosine x as a common factor. You see, so I took out a cosine from here and there. I'm left with this in the parentheses. Now, because I have this thing times this thing equals 0, by the zero product property, what we do is we set each piece individually equal to 0. So this equals 0 and this equals 0. Now solve each equation. So I like to think of this equation by interpretation. For instance, think of the unit circle. And what this is saying is you want cosine to be 0. Cosine is an x coordinate. So where on the unit circle do you have an x coordinate of 0? Well, that would be actually right here and right there, right? So right here, this location would be 90 degrees. And you know, this makes sense because if you plug in 90 there, cosine of 90 is 0. So this tells us that one of the answers is x is 90. This one also works. This is 270 on the unit circle because 270 there, if you go cosine 270 on a calculator in degrees, by the way, all this should have been in degrees on your calculator. Make sure it's set to degrees. Right here is good 270 because cosine 270 is 0. Okay, like that there. And what about this one here? So let's subtract the 1 and then divide by 2. That'll tell you that cosine of something is -1/2. And again, think of cosine as an x coordinate. By the way, the fact that this is x doesn't really matter. This doesn't really have to be x. I wish they had chosen a different variable like alpha or beta or h or k, something random, something other than x, because cosine actually represents the x coordinate. So the fact that this angle is called x just makes it bad. It just makes it confusing. But anyways, cosine is an x coordinate. Where on the unit circle do you have an x coordinate that says -1/2? If you take out a unit circle, it's going to be up there and down here. There and there, cosine is -1/2. So what is this angle? Again, look at your unit circle. And this one should be 120 degrees. And this one should be 240. So look, technically these four are the answers, but look at what this says. They want us to give them all the exact solutions. Last time they said something like 0, between 0 and 360 for the other two problems. But for these ones, this says all the answers. So we're not going to confine ourselves to 0 to 360 because 0 to 360 is just within one revolution. The fact that it says all means that you have to do this. You have to find all the answers within one revolution. You have to find all the answers within the next revolution. You have to find all the answers within the next revolution, and so on and so forth. So we have to go around the unit circle for the rest of our lives and throw answers into that bag. For instance, 90 works. Yeah, let's go back here. So for instance, boom, 90 works. But you know what also works? If you wrap around 90. If you wrap around a 360 over the 90. If you go over and around, that works. You know how 270 works? So what that means is, look, 270 works. So do a full spin. Boom, that also works. Do a full spin. That also works. Do a full spin. That also works. So what I'm trying to say is that it's not just 90. It's 90 plus every 360 that occurs after the 90. Because the full 360 is back to where you were before. So what we do is we go plus 360 and then just pick like a number K or a number N. And what that means is that you're allowing yourself to go around 90 a full time more than just once. You can go from 90 full circle as many times as you want. And that's what K does, because without the K, it would just be 90 and 360 one time. But we see that we can go around 90 an infinite number of times. So you slap on a plus 360K. And as a matter of fact, it can be plus or minus because you don't have to go counterclockwise. You can go clockwise as well. And as a matter of fact, for all of these, you want to go plus or minus 360K. You don't have to use K. You can use N, whatever. Also, if all this gibberish was in radians instead of 360K, it would have been like 2 pi K. So let me submit to you that these here are the answers. But just as an FYI, These answers could have been written in a more clever fashion. So if you see instead of like 90 plus or minus 360K, if the answer key is like 90 plus or minus 180K, then this part would have been omitted. But if they do that and you need explanation, let me know. But for now, let me just throw that at you. Final answer. This one here. So this is the original equation. And I don't like this right away because of the 2x. I like when it's just x. I don't like 2x. So what we do is we go back to this cheat sheet from the previous video. Note that cosine 2x equals this. So by substitution, that is going to become that. So I'm going to go 2 cosine squared minus 1. 2 cosine squared x minus 1. And then everything else stays the same, right? That became this. These stay the same. Now, why don't you subtract 2 to both sides? Because I want to create a 0 here. And in standard form, this would be 2 cosine squared x plus 5 cosine x minus 3. Now, what I want you to see is that that looks an awful lot like 2u squared plus 5u minus 3 equals 0. Doesn't it? Doesn't this have the same structure as this? It's just this looks less confusing. And what I want you to see is we can learn something from an easier version of that. This has the same pattern as that. And this here can be factored like this. It'd be 2u and u. It would be like this. If you experiment with these numbers, this has this factorization. Because if you multiply this out, if you go like that, you're going to get back the thing before. And what I'm saying is that this is exactly this. Except you would go cosine. So this here, this can be factored into the following. It becomes 2 cosine x minus 1. And here it becomes cosine x plus 3. So what I'm saying is that this little scratch work was just written to help us to see how this can become that. Okay? Now, as before, since this times this is 0, set each of these pieces equal to 0 equals 0. Cosine x plus 3 equals 0. If you add the 1 and divide by 2, that's going to say cosine x equals 1/2. Here, if you subtract the 3, this says cosine x equals negative 3. And for instance, if you go cosine inverse of both sides, cosine inverse knocks out cosine. This is just x. But if you try to take the cosine inverse of negative 3, it's going to be undefined or no solution. So as a matter of fact, anytime you try to take the cosine inverse of any number that's bigger than 1 or smaller than negative 1, you're going to get no solution. So this equation gives us nothing, but this equation gives us something. So how can you solve this equation? Well, you can go cosine inverse of both sides like I did here, and which I could have done there, but I like to do these problems a more different way. I like to do these problems by looking at it logically. Cosine is an x-coordinate. So where on the unit circle do you have an x-coordinate of 1/2? That occurs up there and right here if you look at your unit circle. And the angle there is 60, the angle there 300. So we have x equals 60 degrees and x equals 300 degrees. But again, the directions wanted all the solutions. So all solutions means you go around the circle forever and ever and ever. So anytime it says all solutions, we are prepared to go plus or minus 360K or 2 pi K, depending on whether you're in degrees or radians. So here, just go 60 plus or minus 360N plus or minus 360N. Again, it doesn't matter if it's N or K, just those are the two most popular letters chosen for situations like this. Final answer.